So this is Welcome from SNS College Technology and Department of Computer Science Engineering. So now I'm going to tell about multi-level queue scheduling and multiple level feedback queue scheduling. Uh, so in this session, so multi-level queue scheduling process are easily classified into different groups. A common division is made between a foreground and a process and a background. So these two types of process have different response time and requirements, and so may have different scheduling needs. So in addition, a foreground process may have a priority and externally defined over a background process. So, multiple queue scheduling algorithm partitions the ready queue into several separate queues. So, the process is permanently assigned to one queue. So, generally based on some property of the process, such as the memory size and the process priority or process type. So, each queue has its own scheduling algorithm. For example, a separate queue might be used for foreground and background process. The foreground queue might be scheduled by an RR algorithm, so while the background queue is scheduled by an first come first serve algorithm. So let's look at an example of multi-level queue scheduling algorithm. So with the 5 queues, so they are listed below in the order of priority: system process, and interactive process, and interactive editing process, and batch process, and student process. So highest priority is a system process, and the second highest priority is a interactive process, and third one is a interactive editing process, and batch process, and student process, and multi-level queue scheduling. So each queue has absolute priority over lower priority queues. So no process in the batch queue. So example could run unless the queues for a system process, and interactive process and the interactive editing process were all empty. So if an interactive editing process enter the ready queue, so while a batch process was running, the batch process would be preempted. So another possibility is to be time slice among the queues. So here each queue gets a certain portion of the CPU time, so which it can then foreground and a background queue example, the foreground queue can be given 80% of the CPU time for RR scheduling. So among it, the process while the background queue and receives 20% of the CPU to give it is a process and a first come first basis. So multi-level feedback queue scheduling. So normally when the multi-level queue scheduling algorithm is used, so process do not move from one queue to other. So since process do not change their foreground or a background nature, so this setup has the advantage of low scheduling overhead, so but it is inflexible. So the multiple feedback queue scheduling algorithm in contrast, so allows a process to move between queues. So the idea is to separate process according to the characteristics of their CPU burst, and if a process used too much CPU time, so it will be moved as a lower priority queue. So this scheme leaves inbound input and output bound and interactive processes, so in their higher priority queues. So in addition, a process that waits too long in a lower priority queue, so it may be moved to higher priority queue. So this form of aging prevention and starvations. For example, consider a multi-level feedback queue scheduler with three queues, so number from 0 to 2. So the scheduler first execute all process in a queue 0. So only when queue 0 is empty will it execute process in queue 1. So similarly, process in a queue 2 will be executed only if a queue 0 and 1 are empty. So a process that arrives for a queue 1 will preempt a process in a queue 2. So a process in a queue 1 will in turn be preempted by a process arriving for queue 0. For a multiple feedback queues, it is a quantum number 8 and a quantum number 16, and a first come first serve basis, a multiple level feedback queues. So process entering the ready queue in put in a queue 0. So a process in a queue 0 is given a time quantum of 8 milliseconds. So if it does not finish within this time, so it is moved to the tail of a queue 1. So if a queue 0 is empty, the process at the head of queue 1 is given a quantum of 16 milliseconds. So if it does not complete, so it is preempted and it is put into a queue 2. So the process in a queue 2 are run on a first come first serve basis, but are run only when a queue 0 and 1 are empty. This scheduling algorithm gives highest priority to any process with the CPU burst 8 milliseconds or less. Such process will quickly get the CPU, finish its CPU burst, and go off to its next input out burst. Process that need to more than 8 but less than 24 milliseconds are also served quickly, all the with a lower priority than shorter process. So long process automatically sync to Q2 and are served in first come first order. So with any CPU cycle left over from queues 0 and 1, over from queues 0 and 1. So in general, the scheduling number of queues and the determine when they remote a process to lower priority queues. So the method used to determine which queues process will enter when the process needs to a service. So these are about the multi-level multi-feeder queue. Thank you.